This presentation is on version 4, the Guide to Writing Requirements. Version 4, it's totally integrated with our other products. We have a family of products. We're involved in updating the INCOSE System Engineering Handbook, the technical processes associated with needs and requirements, verification, validation, as well as a section on interface management and a section on traceability. And right now, Tammy Katz has some helpers, and they're in the process of updating the CBOK, System Engineering Book of Knowledge, as well. Our main product is the Needs and Requirements Manual. It's about 450 pages. We're meeting with Wiley, and they're going to publish the Needs and Requirements Manual as an INCOSE product, just like they published the System Engineering Handbook. Because Needs and Requirements Manual is about 450 pages, we have guides that focus on different parts of it and give you a Cliff Notes version. So we have a guide to needs and requirements, about 100 pages. We have a guide to verification and validation, again, about 100 pages. And then this presentation, we're going to focus on the guide to writing requirements. And we've been working with some other working groups where they're going to develop domain-specific guides in the context of Needs and Requirements Manual. On the left is a white paper that we have, Integrated Data as a Foundation of System Engineering. That was the working group's response when the concept of MBSE first came out. And it talks about moving from a document-centric to a data-centric practice of system engineering. And all of our products use that as a foundation document. So our products are elaboration of the System Engineering Handbook, version 5. It's more of a how versus what. When you look at the handbook for a given technical process, there's only room for maybe 2 or 3 pages. They talk about what needs to be done. Those technical processes that we have to deal with, they actually refer to the RWG products for further elaboration. We're presenting system engineering concepts and activities from the perspective of needs, requirements, verification, validation, definition, and management across the system lifecycle. So we don't put requirements, say, in a silo. We're looking at the whole lifecycle. And to successfully pass system verification, system validation, the needs and requirements of the system, as well as system verification and system validation artifacts, must be managed throughout the entire lifecycle. Our products provide practical guidance on the activities required to successfully deliver a winning product that successfully passes system verification, system validation, and meets stakeholder expectations. Needs, requirements, verification, validation are the common threads that tie all lifecycle activities and processes together. The Guide to Writing Requirements has been around for many years, and it's kind of considered the gold standard when it comes to writing quality need and requirement statements. We did release a minor update 3.1 in May 2022. The same time we released the manual and the guides to keep everything in alignment. This version 4 that we're talking about was released in June, just before IS. All of our products are available in the INCOSE store. At IW 2023, I gave several presentations on the Guide to Writing Requirements. Section 1, Introduction and Basic Concepts. Section 2, the Characteristics of Well-Formed Needs and Requirements. Section 3, Characteristics of Well-Formed Sets of Needs and Requirements. And in those presentations, I went into detail on all the stuff. So this presentation, I'm just giving you kind of a highlight of that. In May, I did a seminar for the Chicagoland chapter on writing requirements. And as part of that, I went and did section 4, covering the rules of individual need and requirement statements and the sets of needs and requirements. So all the rules that are in there, we went through one at a time, along with the examples in that presentation. Recordings of these 4 presentations are all available on our INCOSE Requirement Working Group YouTube channel. So if you just go to YouTube and search for INCOSE RWG, you'll find that. And there's a playlist for just the Guide to Writing Requirements. Another product that we have is a 7-page summary sheet. On the upper left, you can see it has our figure that I'll go into more detail on. It shows how needs and requirements, verification, validation are part of the overall life cycle. Then it goes through the definitions. And then there's a section on characteristics for both individual needs and requirements and sets of needs and requirements. It gives a nice listing of all the rules, so you don't have to go paging through the guide to find the rules. It references attributes in the Guide to Writing Requirements, but the detailed explanation of each of the attributes is actually in the Needs and Requirements Manual. And then we have cross-reference matrices that are in the summary sheet, which I'll go into detail a little bit later, between rules and characteristics and characteristics and what's in the needs and requirements manual. This is a handy summary sheet you can download and print out. A lot of people use this religiously when they're working on requirements. The overall organization, we have the introduction, and I'm going to go a little bit more detail on that. There's quite a few areas within that. Section 2 talks about the characteristics and need and requirement statements. Section 3, characteristics, sets of needs and requirements. And then Section 4 has the rules. Appendix A, reference material. B is acronyms and abbreviations. Appendix C goes into a lot of detail on patterns and templates that can be used when you're crafting a need statement or requirement statement. Appendix D is a rule applicability matrix, and I'll go into more detail on exactly what that is. And then, like I said, we have the cross-reference matrices and then the comment form. We went through multiple review cycles, and then during IW, during the presentations, we got a lot of feedback, which was incorporated. So, many thanks to all those that reviewed the guide to writing requirements and supplied comments during all those review cycles. It wouldn't be what it is if we didn't have that input from all the experts in the field that are using it and have practical knowledge of the application of those rules to actual requirements. So what changed? We made major updates to the definitions, and there's some concepts in the old one that we've updated also. Added more emphasis concerning the differences between needs and requirements. It really should be the guide to writing needs and requirements, but we kept it the guide to writing requirements. But you see in all of our products, we have an emphasis of defining needs and requirements, and I'll go into more detail on that in a little bit. Describe stakeholder needs and requirements as compared to the integrated set of needs and a set of design input requirements transformed from those needs. We added a new section 1.11 concerning conditional clauses and ambiguous requirements, and I'll talk a little bit more detail on just what that was. Revise the descriptions and guidance for the characteristics. To make the document a little bit more standalone, we pulled in some of the key figures from the Needs and Requirements Manual, included them in the Guide to Writing Requirements to help better illustrate the concepts behind those characteristics. We added one new characteristic, correct, for sets of needs and requirements. We had correct as a characteristic of individual need and requirement statements, but for some reason we didn't have one for entire set. And one of the things that IW suggested that we add that, so we did. We've updated the rules, tweaked them a lot, changed the rule titles, and there's a distinct definition for each of the rules now. We revised the elaborations of each of the rules. And really a big thing is you'll see all the examples that we gave have been updated. And we added one new rule on decimal format. It's important that whatever format you use to express decimals is you're consistent through all your products, not just your requirements. And I didn't know this, but it was pointed out to me that in Europe and other places, rather than using a period for decimals, some organizations use commas to delineate decimals. And then related to decimals is the concept of significant figures. And so we talked a little bit about the consistency when it comes to significant figures. That was one of our discussion topics that we had at IW also. Before we had, for both the characteristics and rules, we had a table that showed the relationship between the characteristics and rules. There was a suggestion in IW that we put those in a matrix. And so we've moved all those relationships in the matrices. And so they're not included with each individual description of the characteristics or rules. Appendix C was updated quite a bit concerning patterns and templates and increased the emphasis on inclusion of conditional qualifying clauses. And then we added a new Appendix D for applying the rules. Some rules are compulsory for both needs and requirements. Some are recommended for needs, but compulsory for requirements. Some are compulsory for all the requirements. So Appendix D talks about that. And also, some of the rules are very dependent upon the project having a well-defined ontology, data dictionary, glossary. So they have consistency in the use of terminology, not just in your needs and requirements, but consistent use of terminology across the life cycle and all your artifacts, in your models and everything else. We use the same terminology, so to reduce ambiguity and confusion. So that appendix has a column that shows which rules depend upon well-defined terms. And the focus of the guide to writing requirements is really the crafting of the need and requirement statements And so we talked about the needs are contained within an integrated set of needs, and requirements are contained in a set of design input requirements. And this is a little bit different terminology than which actually is used in the System Engineering Handbook, and I'll go into a little more detail on that. But really, it's what we call design inputs. And the concept of design inputs and design outputs is, to me, very informative to avoid problems, because I don't know how many times I've seen requirements that are written and they don't make a distinction between design inputs and design outputs. And you'll see implementation included within your design input set of requirements. And we want to avoid that. So making sure that these are design inputs, and you're not communicating any design in your design input requirements, really helps make sure that you're communicating the right thing in your sets of requirements. Together, the integrated set of needs and resulting design input requirements then are inputs into the architectural definition and design definition processes, which transform those design input requirements into sets of design output specifications to which your system element is realized. Section 1, there's quite a few subsections within it. I'm going to go a little bit more detail starting in section 1.7, some important concepts. One is needs requirements of entity which they apply. So when you see the entity shell, it's very important that we're really clear in writing active voice. So we have project requirements, the project shell, project team shell. We have supplier requirements that are normally contained in a contract and statement of work. And so the supplier contractor shell, and it focuses on activities and deliverables that is expected of the supplier contractor. But then we have also requirements on how we're going to do verification validation. And we call these verification validation procedural requirements rather than verification requirements and validation requirements, to make it really clear what you're really communicating. And then we have the product requirements, which a lot of us are really focused on. So we're talking about our system ventures shell perform some function as a design input, or in a design output, we may say a certain component should be manufactured to certain dimensions shown in the drawing, and that would be a design output. So requirements for different entities should not be mixed together within a single set of requirements. Each set of requirements must include only requirement statements that relate to that entity. And we have several rules that talk about appropriate to level in subject verb agreement to help with that. But I've seen, especially in the construction world, in a lot of sets of requirements that dealt with some requirements were on, say, a building being built, and some requirements on the contractor building the building, but it made it real confusing because they wrote all those requirements in passive voice, and they didn't make it clear which ones were which, and it really messed things up. So we want to avoid that. So keep in mind when you're writing requirements that a lot of times people talk about requirements, but they never specify the entity that they're really talking about. And they also don't talk about design inputs or design outputs. So in that case, it really gets confusing when people are so ambiguous in the use of the word requirements. So that's why we made this distinction. Section 8 talks about needs and requirements. And so it talk about the transformation of stakeholder needs and stakeholder requirements into the integrated set of needs, which are transformed into the set of system requirements. And unlike stakeholder needs, integrated set of needs are well-formed, having the characteristics defined in the Guide to Writing Requirements. The concept of stakeholder needs and requirements that are talked about in the System Engineering Handbook are not the same as what we're talking about, the integrated set of needs. They're totally two different concepts. And approach taken in our products, the stakeholder real-world expectations in the form of stakeholder needs and requirements, or other forms of expression like use cases or whatever, and the problem, mission statement, goals, objectives that are defined with the INCOSE's technical process, the business and mission analysis, and the stakeholder needs definition process. And these are all treated for our particular system of interest as inputs into our lifecycle concepts and analysis and maturation activities, which are conducted for our particular system. One reason we do that is that you don't want to base everything strictly on stakeholder needs or stakeholder requirements, because they're probably going to be incomplete. And there's a lot of confusion between what is a stakeholder requirement and a system requirement. And if you look at the NASA 7123.1, the first process is defining stakeholder expectations. In there, nowhere does it mention anything about stakeholder needs and requirements. It just talks about stakeholder expectations. And then those are what's transferred into your system requirements. The other group also, they don't make that distinction, but 15288, has stakeholder needs and requirements as a means of communicating those expectations. But as you can see in this drawing, those are one of many inputs into the lifecycle concept analysis and maturation activities we're going to do. And as a result of all that analysis, then we're going to define the integrated set of needs. So like I said, stakeholder needs and requirements, as well as the higher level concept needs and requirements feed into lifecycle concept needs definition. And for all of this, it's important that we maintain traceability of all this data and information. So again, the stakeholder customer-owned system requirements are treated as higher level requirements that are inputs in lifecycle concept analysis and maturation activities. You can read in the INCOSE System Engineering Handbook, elaboration for other system requirements, why it's a bad practice for a contractor to try to build based on solely the requirements given to them by the customer. And it explains a whole lot of reasons why you don't want to do that. The integrated set of needs represents an integrated stakeholder customer acquirer view of the system of interest. It communicates the perspective of the system is viewed externally as a black box. When we have multiple stakeholders, there's going to be multiple perspectives, and there's going to be inconsistencies, and some things may not be feasible. And so that's why we treat those as inputs, and then we do the analysis. And then out of that comes our integrated set of needs, which is well-formed, complete, consistent, feasible. So it communicates the stakeholder real-world expectations for the end state once the system of interest is delivered. And that's really consistent with NPR 7123 for NASA. So in the end, what will final acceptance be based on, and what is needed to show the delivered system is fit for use in its operational environment? The integrated set of needs must be well-formed, have the characteristics defined in the Guide to Writing Requirements. The baseline integrated set of needs represents the agreed-to scope. So you talk about scope definition. That baseline integrated set of needs and signed off by the customer says, the customer says, that's what I expect. And I'm willing to provide the resources, the time and money to implement a system that meets my needs. The requirements to design the system of interest are validated against the integrated set of needs. And this is one difference in the way the System Engineering Handbook and 15288 define validation. They define validation as against the stakeholder requirements. That's been around for a long time. There's a lot of problems with that approach. And so in our products, we try to remove that confusion and ambiguity by having a well-formed integrated set of needs that you validate against, and then you verify against the design input requirements. It's always been confusing to me when you see, oh, validation is against requirements and verification against requirements. It just doesn't compute right in my brain. So a key point is that the integrated set of needs is defined, owned, and managed by the customer because it defines this agreed to scope. And so it's only the customer that has the right to define what their needs are, not the suppliers or developers. So you can't tell the customer what their needs are. You can critique the needs and tell them if there's problems with it, but in the end, it's the customer that owns that scope, what they're paying for. Then we have the design input requirements. Now we're going to switch perspectives. They're the technical development view of the system of interest, which is referred to as the system requirements, and they transform the integrated set of needs. So they communicate the perspective of the system as viewed by the developers, the transparent box. Now I'm looking inside the box and I'm getting into more details. They're expressed as shelf statements. The needs are not expressed as shelf statements. For a goal, you can use should. And these are what's input into the architecture and design definition processes. And it never ceases to amaze me at how many people think that architecture and design are the same processes when they're two distinct processes. The design input requirements are validated against the integrated set of needs, and both the design and realized system of interest is going to be verified against the design input requirements. And the quality of your requirements then is dependent on the quality of the needs for which they're transformed. If the needs aren't complete, if they're inconsistent, if they're not correct, if they're not feasible, then any requirements that are transformed for that set of needs are probably going to have that same set of defects. So if the integrated set of needs doesn't have those characteristics, you're going to have problems. So when I talk about two different perspectives, you're looking at the stakeholders. In this case, it really is not just the customer, because the customer doesn't have all the knowledge. And so there's other stakeholders that are involved in some way across the life cycle. What do we need to do when using the system? What do we need the system to do? What quality do we need the system to have? What do we need the system to comply with? Your standards and regulations. What external systems do we need the system to interact with? And so they're looking at it from black box and they're asking those questions, and then they're describing the black box in terms of these questions. When we switch perspectives now for the design input requirements, we're saying, what does the system need to do to meet the needs that we defined? There's different levels at the strategic level, the business operations level, your system level is subsystems, system elements. The stakeholder real world expectations, lifecycle concept needs and requirements exist at each level. Stakeholders communicate their expectations in various forms. You have stakeholder needs and requirements, but also people use use cases, user scenarios, stories, operational scenarios. And so you can see from one level, there's a flow down, and what's defined at one level constrains the next level down. And then we go through all these processes. The section 4 that's talked in here is section 4 of the needs and requirements manual. Section 6 is also the needs and requirements manual as well. When we're defining the integrated set of needs, we solicit all the inputs, then we do the lifecycle concepts analysis and maturation and develop a set of lifecycle concepts, and then those transformed through needs analysis into the integrated set of needs. And then we validate those needs back against the inputs, which include validating against the stakeholder needs and requirements. And then we also verify that we've written the needs properly per the organizational rules for that. The stakeholder real world expectations include stakeholder needs and requirements, as well as higher level needs and requirements defined during the business mission analysis and stakeholder needs and requirements definition processes as defined in the INCOSE System Engineering Handbook 15288. Section 19 talks about the quality needs and requirements. When defining the needs and requirements, it's important that they have the characteristics defined in this guide. These characteristics are a result of following the rules defined in the guide, as well as performing the activities associated with the definition of needs and requirements discussed in the needs and requirements manual and the guide to needs and requirements. It's the underlying analysis from which a need and requirement was derived is as important as how well a statement is formed. So a requirement can be well formed following the rules in the guide, but yet not be correct or feasible. That's a big change. Before, people say if you follow the rules and you're going to have a well-formed statement, then you got a good set of requirements. And we're saying not necessarily. They are formed right, but they could be the wrong requirements and may not be feasible, or your set may be incomplete. So just being able to follow the rules is necessary but not sufficient. But to help ensure the needs and requirements, sets of needs and requirements have the characteristics defined in the guide. For each characteristic, there's traceability between both the rules in the guide and the concept and activities discussed in the needs and requirements manual. And again, that's a big change from past versions of the guide to writing requirements. Writing needs and requirements is not an exercise in writing, but it's an exercise in engineering. Section 10 goes over the needs and requirements in context of verification and validation, showing how everything fits together. This is a popular diagram. If you look at the new System Engineering Handbook under technical processes, the first section of that, you'll see a diagram that was derived from this one. Instead of verification validation context, that diagram talks about all the lifecycle concepts in context of each other. Section 11, a new section that wasn't there before, it talked about conditional clauses, ambiguous requirements. Finding 29.148, your requirement statement is translates, expresses a need and its associated constraints and conditions. Requirements without a condition, then it's referred as ambiguous. It's requirements which are requirements do not require a condition or context which triggers the desired system response. So basically, ambiguous requirement applies across the board, independent of any triggers or anything else. It's a generic characteristic or expectation for the system. Your requirement sets need to contain both ambiguous and non-ambiguous requirements. In the past, I've seen a lot of requirements that did not state the conditions. And in essence, what we're talking about now is if a condition does apply and you don't state the condition, then your requirement's not complete. And we have rules that talk about that. A good example is if I have a requirement, the system shall have a lifetime of so many operating hours, period. And that's how we a lot of times would communicate lifetime. But if you stop and think about it, you're missing two key conditions. If you say The system shall have a lifetime of XX hours when maintained per some maintenance procedures and operates in the operating environment that it's supposed to. Now it's a lot more verifiable because you've included those conditional statements to make it clear what's contributing to that lifetime. And if it's not operated properly, then you can't expect it to have that lifetime. So it's a combination when we're defining requirements to treat non-ubiquitous requirements as ubiquitous, failing clearly to communicate those conditions. And so this results in requirements that are not unambiguous, complete, correct, or verifiable. When defining requirements, describing the desired system response for an action performed by a system, subsystem, or system elements, it's necessary to avoid the use of ubiquitous requirements as much as possible. Say another way, it's important that we include those conditional statements and conditions of use when we're writing requirements. And it also aids in consistency requirements, and also from a modeling standpoint, by stating the function, but also stating the trigger. All of you that are developing models, you say, oh yeah, that really helps me develop the model because now I know what triggers that function being performed. This concept has been commercialized in approaches such as EARS, Easy Approach to Requirements by Maven, and several natural language processing and AI tools that are used to assess requirements quality also refer to EARS in doing that. The Guide to Writing Requirements has several rules that talk about conditional clauses. And Appendix C, again, patterns, goes into more detail on that also. Section 2 gets into the characteristics of individual need and requirement expressions. And in our definitions for a need and requirement statement, our definitions have two parts. One talks about a formal transformation. The other talks about an agreed to obligation. If a requirement is a formal transformation from needs, then you'd expect that requirement to have the listed characteristics. It's necessary, it's appropriate to level, it's singular thought, it's correct, and it conforms to our rules for writing well-formed requirements. And from agreed to obligation standpoint, you would think that you'd want the requirement to be unambiguous, you'd want it to be complete, feasible, and verifiable. And so you would think that when we have a contract and the contractor is looking at a set of customer supplied requirements, they would want requirements to have these characteristics. Else, why would you sign the contract? If you know your requirements are not complete, they're not feasible, they're not verifiable, you're crazy if you sign that contract in many cases. Unless it's a level of effort, then you make money off the poorly written customer requirements. Section 3 talks about characteristics of sets of needs and sets of requirements. Again, we have a formal transformation. So you want the set itself to be complete. You want consistency within the set and also consistency with that set with other like sets for the system. And you want that set to be a correct set. And again, the set from an agreed to obligation, even though individual requirements may be feasible, you'd want the set as a whole to be feasible. You want comprehensible. When people read your set of requirements, you would expect them to clearly understand what is they're supposed to build. The set needs to be able to be validated for both the needs and requirements. So again, from a contract standpoint, you would think that you would have these characteristics. Now, I've been asked a lot of people say, well, in the world of MBSE, and they're defining MBSE to be SysML models, which is not. SysML models is just a tool that's part of MBSE, but it is not MBSE. Some people may not agree with that. But one of the statements is, well, if we express requirements in a model, do we need text-based requirements anymore? My answer is yes. And we have a section in the guide that talks about the advantages of text-based requirements. And we also make a point that we're not talking about natural language. We're talking about a structured natural language so that the requirements follow the rules, so they are structured. The general statement that's in the Guide to Writing Requirements is that if you want to express requirements in a different form, then they still need to have the characteristics. You can go through each characteristic. You can ask the negative, what if the requirements in this other form are not complete? They're not consistent. If you put a not in front of all the characteristics, for both the sets and the individual ones, it makes it really clear that whatever form you're using, you still have a poorly formed set of requirements. So it's something to always ask yourself, whatever form you use, can I still say that my requirements have these characteristics? The format of the characteristics, there's a title, there's a definition of each characteristic, there's rationale, why that characteristic is necessary, and there's guidance. And you can see we pulled some of the figures from the needs and requirements manual to help illustrate those characteristics in better form. There's lots of characteristics, and so that can get kind of confusing for people. So there's different ways of dealing with that. You probably heard about SMART requirements. And unfortunately, when you look at SMART, the original acronym SMART applied to goals and objectives. They didn't apply to requirements. So we've redefined SMART in terms of the characteristics that are defined in the Guide to Writing Requirements. So specific, measurable, appropriate, realistic, traceable. And like I said, these were originally applied to goals and objectives. They're modified to be more applicable to the needs and requirements based on the characteristics in this guide. And then there's CQDEF, correct, consistent, complete, feasible. And these are really applied to sets of needs and requirements. And you see that these four are used over and over again in the needs and requirements manual. When we talk about it, well-formed sets of needs and requirements. And correctness, completeness, consistency are three most common characteristics used in a lot of natural language and processing AI applications. The reuse company, their products as an example. And then we have VAN, verifiable, achievable, necessary. In the classes that I taught over 20 years, we had these three that we talked about. I worked for Ivy Hooks and the classes that we did. And then Ron Carson has added to this efficient. He represents four main characteristics that he proposes, and he makes a distinction between necessary and sufficient. Those four characteristics take into consideration the dependencies and overlap of the 15 characteristics discussed in the guide. He proposes that if these four characteristics are present, then the need and requirement statements are correct. And if the needs and requirement statements are correct, then the sets are. Diagram that shows that you have the VANs result in individual needs, which result in complete and correct sets of needs and requirements. Section 4 gets into the rules for writing well-formed need and requirement statements and sets of needs and requirements, provides set of rules that contribute to the requirement statements having those characteristics of well-formed individual requirement sets of requirements. Like I mentioned before, while following the rules is necessary, it's not sufficient. And so the overall quality of our requirements is also dependent on the concepts and activities defined in the needs and requirements manual. So the rules and needs and requirements discussed in the guide to writing requirements, again, apply to needs and requirements for any entity, no matter which level in an organization that entity exists in architecture. So the rules are formatted. Like I said, one of the changes are we have a very distinct name now for each rule. We have a clear definition for each of those rules, some elaboration, and then we give examples of unacceptable and improved. And then if there's any exceptions or relationships, then we include the exception relationships. So for all the 42 rules, you'll see this kind of a format in the guide. And so like I say, we have the rules characteristics, the cross-reference matrix. So you can see the 42 rules that are listed here. And then they're mapped across to the 15 characteristics that we define in the guide, how they contribute to that. But we also have this matrix where we take different sections within the needs and requirements manual and map them to the characteristics also. So again, if you want individual needs and requirements and sets to have the characteristics, you have to address both the concept and activities in needs and requirements manual as well as the rules. And then I talked about rule applicability. Appendix D is brand new. It was added in this new version. So it helps practitioners tailor the rule set to be used to either assess the quality of need statements or requirement statements, providing them with guidance about optional or recommended rules applicable to needs before applying those to the requirements transformed into those needs. Guidance as the selection of appropriate sets of rules. And then each rule is assigned a specific level of applicability, compulsory for needs, compulsory for requirements, recommended for needs, compulsory for requirements, or compulsory for requirements, optional for needs. It also provides guidance about the need for a project dictionary so that you make sure all the terms you use are defined someplace so you have consistent use of terms. The matrix, there's a row for each rule. And then you have the applicability in here and also the rules that have to do with project dictionary, glossary, or whatever. It talks about that. And then there's some comments to deal with that as well. So that concludes the presentation. So now we're open for any questions that anyone may have.
All right, Lou. No, that's great. There's a lot of rules, a lot of characteristics, and I saw you I like that section about like the easy, the smart, the van, different ways that you can convey all this in more simpler for people that are laymen and just trying to learn how to write requirements and just kind of want it easy. What is the best way, do you think? Is it those like van, smart? Is that the best way you can think of how to instruct like your team? Like your engineers that aren't system engineering requirement experts, but you're trying to get them to help you provide and trying to get a team to evaluate requirements. Do you just go with the basics, simple, concise, complete, appropriate, verifiable, and just do the smart and start with that?
You want to start with that. You want to focus on the characteristics first, but then to help with those characteristics, you have to understand what activities help lead into those characteristics. And then you have the rules. And like you say, there's a lot of rules. And how do you keep track of all that in your head? So fortunately now, there's several vendors that have developed tools to help assess the quality requirements against a subset of the rules. They can't do all the rules yet, but at least a subset. So like the reuse company has requirement authoring tool that will help you do that. IBM has a tool, QV Scribe. JAMA Connect has just added a requirements advisor that does an assessment of your requirements. And so you have the capability of a digital assistant that will help you follow a subset of the rules. So the obvious rules about ambiguous terms and so on, those tools can help identify those rules for you so you don't have to keep track of all of those. And then just experience is going to be important. So it's good to have someone in the team that really knows what the rules are. And so when you're doing the assessment, they can point out to things. But in the end, it's really more about the characteristics than it is the rules. The rules just help you with those characteristics. Unfortunately, a lot of the tool vendors focus just on a subset of the rules, and they really aren't able to do much assessment of the characteristics because that actually requires intelligence. It requires thinking on the system engineer part.
Yeah. So think about those activities to get you that actually a good requirement. That's technically the intelligence part. So is that just really goes into the system engineering processes, the trade studies, the actual engineering work to develop the requirements decompose appropriately. Is that a good take?
Oh, yes. But it's also important to understand the technical processes are not meant to be done in a silo, and they're not meant to be serial one after the other. They're meant to be practiced concurrently. When I'm in that lifecycle concept and analysis phase, I want my system architects and my design team to be part of that activity, because one of the things about feasibility is the technology readiness levels. Feasibility is in the physical world. It's not in the conceptual world. Conceptually, I can envision things having no weight, but that's not real. I can envision going faster than light, but that's not real. And it's the design team then that has to really look at technology readiness levels, because it's the designers that are going from the conceptual architecture to the physical architecture. So it's the design team has to say, do we have a technology that will allow us to do that? So it's very important that we have an integrated multidiscipline team and we look at all this stuff concurrently. So your architects and designers are actually helping us design a feasible, complete, consistent set of needs and set of requirements.
So yeah, you bring the design team in, because you need their stakeholders, you need their input. Do you set ground rules and kind of prep them? Design engineers, they just want to start making design requirements, right? And you're still at a system level. You just want their input to make sure that you're not telling them to do something impossible. So do you do a lot of pre-work of the setting the expectations and guiding them in the appropriate level?
Part of that's going to be traceability. A designer will want to jump into a design. So you ask them, okay, why? They should be able to communicate the why in the terms of the design input. Well, I need this design in order to meet this design input requirement, and I need this design input requirement in order to meet the need. Again, that's where you have bidirectional traceability. So if they want to dive into design right away, you got to pull them back and say why. It's got to be traceable to something.
Okay, terrific. Anyone else have any questions?
Hey, Lou, Can you give an example of ubiquitous requirements? Had conditional requirements. What's an example of a ubiquitous?
To me, at the system level, you're going to have more ubiquitous requirements than at the lower levels where you have more conditional statements. The seminar that I taught in May, it was about a robot that puts lids on jars. So I had some requirements that just said the robot shall place on jars lids that have these characteristics. That requirement is just talking about what are the characteristics of the lids that it has to be designed to be able to interact with. Then I had another one that said the robot system shall put lids on jars having certain characteristics. And so then I'm just talking about, the whole purpose of the requirement is that the robot has to be able to interact with the jars with those characteristics, the materials and the size, and be able to apply the right torque. And then it's interacting with another system that's supplying the jars. So it has to be able to put lids on jars that are positioned per some ICD, or that has to be able to put lids on jars per timing defined in an ICD. So there's a bunch of generic things that apply to the robot at the system level that I need to define up front. But now when I get into a lower level, then I need a trigger. When am I going to go and put a lid on jar? How do I know the jar's in place? What tells me that? Now I got to start putting in the conditional requirements at that lower level so that I have those triggers so I know when I need to perform key activities.
Gotcha. And my other question is, I'm taking a course on UAF. They
Yeah.
have these different layers of the business case perspective, and then there's the system perspective, and then there's a couple other ones.
In reality, the business case should be from a needs perspective, where you look at the system from a black box. You don't want management telling you what's inside the box. You just want them to describe, we need it to have this functionality. We need it to have this performance. We need to have this qualifications. We need it to be able to interact this way. We need it to comply with these standards and regulations. That's all the level detail you want them to talk about. That chart I showed you earlier about questions the needs do. So they may not be called needs. They may not be called the integrated set of needs, but they are how they're communicating their expectations.
Okay. And then my last question is, when we were in the oil field and oil and gas, we use SMART because it was what I call tattoo proof. You put a tattoo on that and they won't forget that. And I used to draw the line between, according to Lou's diagram, the design inputs and design outputs, and say at that border is where you go from the problem to the solution space. And there was a lot of requirements that were process requirements, and that was a pain in the ass.
Oh, so his rule about you don't mix those type of requirements.
Yeah, so getting them to separate that in a different set of documents, very difficult, because they have a lot of tradition in terms of, I built this Christmas tree, and these are all his requirements. Well, where do they come from? Well, 20 years ago, we figured it out.
Yeah, but no one knows why, because you never wrote rationale.
But it worked.
Yeah.
And that guy who wrote it, the guy who did it, he's retired. And
learned about rationale, Lou, since you mentioned that. So we're working with a team on the other side of the ocean on my project. And when we first started going into requirements, they didn't have rationale. Their requirements were definitely not as structured as ours. They were kind of like a one thought, and it did kind of have rationale in it a little bit. And when I introduced, no, we got to change this. This is my expectations for requirement format. And I said, rationale, where you get that? And it was actually, I had to explain to them that we could deliver rationale with the set. That's the rationale and the actual requirement go hand in hand. And that was actually new to them. And that was new to me, that I thought this stuff was borderless. I thought this was like system engineering going. But having a title, a shall statement, and a rationale, that's apparently not as widespread as I assumed. So my real question for you is, what is the commonality of the different international countries and how they handle requirements? Is INCOSE with this? Are we trying to make that common bridge between everyone?
Look at the membership of the requirement working group. Yeah, we got members from all over the world. We've had chairs of the requirement working group from Europe. The guide to writing requirements, the original version was led by someone from England, Jeremy Dick. INCOSE is trying to provide that common language, independent of product line, independent of country. A couple points back on the other question. On this drawing, all the orange things at the bottom are little requirements on the organization. So when you're looking at a set of requirements, sometimes that's also they'll have a requirement on what the people are supposed to be doing. Like in the middle, what are the requirements on how you do architecting? What are the requirements on how you design? In the oil and gas world, a lot of the requirements are actually design implementation kind of stuff. When you're doing a pump, you need to have this feature, but they never say why. They just show you a drawing and say, if you're going to do it this way, you got to do it per that drawing. There's no rationale. It's surprising to me that organizations don't define requirements on how they're actually going to do the work, because all of that tribal knowledge needs to be captured someplace. It's requirements basically on the people that are doing the activities. When you look across the middle of this diagram, the word transformation occurs in between each of the boxes in the middle. And so the orange boxes are pointing up to basically how you can do that transformation. And so organizations should define requirements on how that's going to be done. But if you're going to have issue a contract out to a vendor, depending on the type of contract, you would probably want to have requirements on how the vendor is going to do those transformations also, at least from an activity and deliverable standpoint. The other thing we just talked about on the upper right here, it lists 49 different attributes. The needs requirements manual, last chapter, goes into a lot of detail on those attributes. There's a reason for each one. So when you're defining your schema, when you start a project, for every need and every requirement, you need to establish which of the attributes are going to be defined. And rationale is so important. I've worked with organizations that didn't have rationale. I had them write rationale, and many times they got rid of half their requirements. And how many times there's a requirement that has a number in it, and nobody in the organization can explain why that number is what it is. It's kind of scary. And just like the oil and gas, do you have anybody around that can actually explain why you need to build something per that drawing? A lot of times the answer is no.
Usually not. That answered my question there. Thanks, Lou.
Yeah, no, thank you very much. So any other questions online or anyone else in the room? Thank you for everyone's time. Lou, thank you very much.